So, converting verbal information into vector information takes some doing. So, I'm calling it pictorial to vectorial. I like playing these kinds of games, so just humor me, okay? So, pictorial to vectorial. What do I mean by that? In the pictorial side, we talk about magnitudes and angles. On the vectorial side, we talk about fx and fy. We talked about this. On the pictorial side, we will talk about net force, resultants and things like that. On the vectorial side, we will talk about sum of vectors. So, when you see the word resultant or net force, the corresponding vectorial idea is sum of vectors, adding the vectors. In the pictorial side, we will talk about directions. On the vectorial side, it's a unit vector. Unit vector means vector of unit magnitude. Okay? On the pictorial side, you might talk about force along a line or force parallel to a line. On the vectorial side, it is called component along unit vector or dot product with unit vector. On the pictorial side, you might talk about perpendicular to a line. On the vectorial side, you will talk about cross product with unit vector. On the pictorial side, you might talk about perpendicular to a surface. On the vectorial side, you talk about dot product with normal vector. So I wanted to see how the pictorial and vectorial cases change. This thing, pause this particular slide and write this down on in your notebook and keep this page open. Please do that because we will be referring to it. It's a very easy way to actually convert verbal problems into vector problems. Okay, so did you pause it? Have you copied it down? Very good. Now, let's time for an example. So, you have a stone wall and you have what is called an eye bolt. This thing is called an eye bolt. This thing, you know why it is, right? It looks like an eye, right? And there is a cable that goes through and there are two forces on it. First force, now I have deliberately not marked the forces directly on the picture because when you look at real life, you might see these cables, but you won't see them marked with F1 and F2 and angles and all of that. You will only be given a verbal description. So we want to be able to convert that into a picture. So here it goes. It says one has magnitude of 1100 newtons, making an angle of 70 degrees up from the horizontal. Which one do you think that's going to be? Is it obvious to you that this is the first one? F1 equal to 1100 newtons at 70 degrees from the horizontal. The other one has a magnitude of 1200 newtons, making an angle of 80 degrees below the horizontal. So this is F2 at an angle of minus 80 degrees, which is 360 minus 80, which is 280 degrees. You see how I converted these two things? So now we are going to draw a nice picture, sideways picture. That is, I'm going to look at it like that so that you can see this better. So here is my eye bolt, here is the wall, here is the attachment to the eye bolt, here is the horizontal, this is east. Okay, now first is F1, second one is F2. Of course, the angles I have not drawn are not correct. 70 degrees will be a lot steeper. 70 degrees this way, 80 degrees this way, and that turns out to be 280 degrees that way. Okay, so I got two forces, 1100 Newton at 70 degrees and 1200 Newton at 280 degrees. Now we are all set. We know what to do. We will come back. But the point is, it says find the resultant force. When I am reporting forces, I am always reporting magnitude and angle. I am not going to report fx, fy unless I am specifically asked for. This is what is useful to do translations. So you see, I have to go back and forth between all of these different things. So let's see. We have to now, in order to be able to report back and forth, we talked about how to convert from pictorial to vectorial. Now we look at how to convert from vectorial to pictorial. So what I have given, you are given Cartesian coordinates and you want to find polar coordinates, magnitude and angle. Magnitude is pretty easy. It is square root of fx squared plus fy squared. There is nothing to it. Angles, you have to be careful. And the method that I am going to tell you, remember I always tell you royal root, right? That means method that always works is this. The angle is given by, take the sine of this. Sine means whether it's positive or negative. So notice that's what this means. Times cos inverse of fx over f. Don't do that, because then you have to sit there and figure out which quadrant these things are, and it's a headache. If you do this, this will always work. I always tell you royal root, then it will always work. Okay. Okay, so now let's get back to our problem. Here is our original problem. Here was our figure. $1100 at 70 degrees. And then we had 1200 newtons at 80 degrees down, which is 280 degrees. So I'm just going to change the color so that you can see. Notice the base of both of them are here. So if I want to convert it from pictorial to vectorial, I have to draw east and north at the base. So I can draw it from here. This is east. This is north. Okay, and our angles are all nicely marked. So now we are ready to do the calculation. It tells us that F1 so I'm going to write it here. F1 equals, now this is a vector, equals 1100 cos 70 degrees, comma 1100 sin 70 degrees, which is 376.2, and this units are Newton, 376.2 and 1033.7. You can see that the y component will be quite a bit more than the x component, so this number seem okay. F2 will be, notice how I write it, 1200 cos 280 degrees, comma 1200 sin 280 degrees. I don't care about whether it's positive, negative, whatever, because I am doing counterclockwise from the east direction, which turns out to be 584.6, comma minus, sorry, 208.4, I'm sorry, 208.4, comma minus 1181.8. You can calculate this and you can see. Okay, so what is F1 plus F2? Turns out to be 584.6, comma minus 148.1. All I did was just added the x components, this and this, and added the y components, this and this. Okay, now I want to convert it. So notice we went from picture to vector. Now from vector back to picture. So that means I have to find magnitude is square root of 584.6 squared plus 148.1 squared, which turns out to be 603.1. And that had better be a positive number, and units is Newton. Angle, so this is Fx, this is Fy, this is F. Is sine of Fy, so it is minus 1, that's the sine of this, cos inverse of Fx 584.6 divided by 603.1. You see how I did that? This is the sine of this. This is the other one. That turns out to be minus 14.2 degrees. So what does it mean? I want to draw this now in like green. So it's going to be, look at the size of this, 1100. So that's about the weight of one person. Whereas look at the size of this, that's about 603 newtons. Roughly about, 1100 is weight of about 2 persons. So this is about the weight of about 1 person. So it's about half the size. And the angle is minus 14.2. So I'm going to draw it here like that. So this is 603.1 Newton and this angle is 14.2. Of course, you can convert this angle. This turns out to be whatever 360 minus 14.2, which is 0.8, 359, 345.8 degrees. If you add those two things, I should get 360. No? So that's it. You got the idea, right? Very good. So we have gone through this in a kind of a painful way, but we don't make mistakes if you do this, or if you make a mistake, you can recover. The last point is something that I want to make about getting trigonometry right. So if I give you a triangle like this and I ask you to find out what is the cosine of this angle, you are probably thinking cos theta equal to adjacent over hypotenuse, right? And that will work for this. What about this angle? You can't do adjacent over hypotenuse. What is adjacent? What is hypotenuse? Where is the hypotenuse? Is this the hypotenuse? Where's the hypotenuse? So it turns out you cannot do it that easily. Okay? And forget about these cases. If I give you this angle and if I give you this angle, right? The correct way to do that is the following. Please do not make this mistake by memorizing it as adjacent side versus hypotenuse. It's much better to remember sine of an angle is the counterclockwise of the counterclockwise angle is y component over distance between the ends. So what I'm going to do is I'm going to say, okay, this is the y component, distance between the ends between the two vectors. This vector is how it works. Like that you can do for all of them. Y over r, y over x squared plus y squared square root is what I mean, and x over x squared plus y squared. This is sine theta and this is cos theta. Don't try to remember adjacent by hypotenuse. So we will ban that stuff. So think about this is x over square root of x squared plus y squared. This is y over square root of x squared plus y squared. Forget about all this adjacent by hypotenuse, all of this thing. You just go here and you say, okay, x component, y component, x component. Notice x is in the negative direction. So this will be y over x and calculate it. I mean x over square root of x squared plus y squared, calculate it and do. Okay, that's how you are guaranteed that things will work. Thank you.